Hello friends, we are going to discuss about manufacturing process of crankshaft. Myself Irfan Altaf Jamadar from Rajaram Bapu Institute of Technology, Islampur. My PRN number is 22560033. Introduction. The crankshaft is located in the engine of the vehicle and converts the force created by engine's piston moving up and down into a force that moves the wheels in a circular motion so that the car goes forward. It is located inside the car's engine and it is connected to all the pistons in the engine and to the flywheel. To understand this shaft, it is important to understand how the piston and the flywheel works. These are the some main parts of the crankshaft, like mount for crankshaft drives, pockets, crank pin, journals, main journals, web, flywheel mounting flange, etc. Main parts of the crankshaft. First is web, the portion of a crank between the crank pin and the shaft or between adjacent crank pins, called also crank arm, crank throw. Second is counterweight. Crankshaft counterweight are needed to statically and dynamically balance the crankshaft. Without them, the vibrations caused will destroy it. If this is not done, the engine will experience vibrations that will eventually tear up the main bearing and cause damage. Then crankshaft journals. In a reciprocating engine, the crank pin, also known as crank journals, are the beak and bearing at the end of the connecting rods opposite to the piston. Crank journal pin. The oil passes through the ammonium crank with holes and passes the oil inside the tube into the column to the spike and the connecting column. The oil reaches the crankshaft through a pump located inside the oil filter. This is the figure of crank journal pin. Then flywheel. Flywheel is bolted and fixed connected to crankshaft, and we cannot differentiate on microscopic time scale the power stroke or suction stroke, or in which stroke the flywheel is storing the excessive energy. Flywheel just stores the excessive energy in the form of kinetic energy, and immediately after power stroke crankshaft uses it in other power strokes. Flywheel rotates with same speed as crankshaft. Then the material selection for crankshaft. Based on the stresses imposed on the component during the operation and operating temperature, the materials to be selected for this component should have the following characteristics. First, the material should be strong in bending, and it must have excellent fatigue resistance. It must have less coefficient of thermal expansion so that the component can retain its original dimension at varying temperatures. The material should be easily machinable so that it can take complex shape as required for the geometry of crankshaft easily. After carrying out an extensive research of material, following materials were listed for crankshaft, such as aluminium, copper, and steel. First is aluminum. Aluminum is an excellent machinable metal. It can take complex shapes easily. Moreover, it can absorb vibration very efficiently. However, the metal has lower modulus of elasticity and higher coefficient of thermal expansion. Therefore, it will be subjected to larger stress at higher stresses and high temperatures. Moreover, it does not have good resistance to fatigue and corrosion. Second is copper. It is easily machinable and has high strength. Moreover, it has good surface finish which reduce friction. However, the biggest disadvantage of copper is that it is not corrosion resistance. Corrosion rate is higher at higher temperature. Then steel. Steel is another option to be used as a material for crankshaft. Steel is a better choice because it possesses excellent mechanical characteristics which make it better for crankshaft. It has the highest modulus of elasticity. It is tough, strong. easily available, cheap, and it has very less coefficient of thermal expansion, which makes it best suited for high temperature operations. An option of an option for crankshaft material is carbon steel. However, these steels require additional heat treatments to acquire required level of strength. Iron crankshaft is also an option. However, iron cannot take higher loads. Therefore, iron crankshafts are suited for low output engines where stresses are lower. They have the advantage of being low cost. In fact, the most widely used material for crankshaft worldwide is microalloyed steel. It has following advantages. Microalloyed steel can be air-cooled after reaching high strength without further heat treatment. Low alloy content also makes the material cheaper and high alloy steels than high alloy steel. Mechanical properties required for crankshaft. This is the some mechanical property like tensile, yield, elongation, reduction. Then the manufacturing process. Typically in the crankshaft manufacturing process, a billet of suitable size is given a heat treatment till the required forging temperature, and then it is successively pounded or pressed into the required shape by pressing the billet between a pair of dies under high temperature. If there are complex shapes or extreme deformations to be achieved, then more than a set of dies are needed to get the task done and accomplish the right shaping. Crankshaft can be cast or forged. Forging has some benefits over the cast crankshaft, such as forgings are stronger because of the hot and cold work that lacks in a cast crankshaft. Forged crankshafts are stronger than and more durable. Forging ensures a higher strength of parts and components. Forging are inexpensive and reliable. There are a number of possible casting defects that can seep into your crankshaft. Since hot working departs the product qualities like resistance, ductility, and strength, uniform heat treatment response. Casting need a control over the melting and cooling processes for the fear of alloy segregation. The manufacturing process. This is the flow chart of manufacturing process. First is raw material input, raw material inspection, cut to rough dimensions, furnace heating, preforming dies, rough shape of the crankshaft, forging, first define shape crankshaft, trimming, coining, short cleaning, etc. These are the forging process, and then this machining processes. The main manufacturing process of the forged crankshaft is hot forging and machining, and this is shown in the flow chart. First, the raw material samples of the AISI 1045 are inspected for chemical composition. The material is shaped and cut to the rough dimensions. The shaped material is heated. Note: AISI 1045 carbon steel has melting temperature over 2660 degrees Celsius. Fourth is the forging process starts with the preforming dies, where the material is pressed between two forging dies. Then the forging process continue with the forging of preformed crankshaft. Then trimming process. Trimming process cuts the flash which is produced and appears the flat uniform metal. Then twisting for second and fourth main generals. The exact the exact shape of the forged crankshaft is obtained in coining process, where the final blows of the hammer force the stock to completely fill every part of the finishing impression. Then the inspection and the machining process starts with the facing and centering process. Then cam turning is process used to produce cylindrical component typically on a lathe. Then then the drilling operation, all inner diameters are drilled. Then the final grinding. Then the final final step in grinding is phase grinding. The last step in machining process is balancing the crankshaft. Then final washing component and preparation for final inspection, and the lastly component is inspected and the heat treatment is the next step to obtain desired mechanical properties for the material. Here are the some forging defects. Forging provides the best mechanical properties out of all manufacturing process, but that doesn't mean it's faultless. There are some forging defects like unfilled sections, scale pits. Scale pits are also some of the most common type of forging defect. They are all cracks or holes in the metal that occur due to improper cleaning of forged surface. Then die shift, surface cracking, flags, cold shut. Cold shut is defect is when small crack appear at